At the Auburn University expansion project, Nate Bush and Gage Botcher are trying out a newly released visual measurement tool designed for quick, easy field measurements. While it can be used for a variety of tasks, they're measuring stud beam placement to see just how user-friendly it really is.
Those stub beams aren't in their final resting position. Right now, I just have them flush with the concrete. That concrete's a little out. You can push that beam up or down.
Yeah, especially because you're cantilevering out from the edge.
I just want to see how far they're off elevation-wise.
Okay.
This advanced 3D measurement and layout sensor uses computer vision to track a sphere mounted on a survey pole. A logic module analyzes mathematically positioned markers on the sphere to calculate its distance and orientation, enabling precise 3D measurements. Nate provides Gage with a brief overview of the system's basic functions, hoping it gives him just enough knowledge to test the system and perform the stud beam measurements on his own.
It's going to store a picture every time you store a point. So when you go look at your point information, you can say, oh, that's where that point was at.
Exactly where it is.
Yeah, know where it's at. So anyway, we're going to use the V-sphere, this tall pole here, and we're going to check that guy on. We have the option to use tilt, which we will. So if I go into my targets, I have auto height set up. That means the camera is reading these white stripes, so it knows it's in this lower position. And then tilt on. We can turn it off and use the bubble if we needed to, but yeah, I mean, it locks on pretty fast. There it goes. So now it's locked on. Now it's just tracking me wherever I go. So it's pretty fast.
It's very fast.
You know, if I was to block it intentionally and lose it, as soon as I turn back around, once it's in the camera field of view, it just locks on.
It'll find it.
So for you, what we can do, and I'll go up there with you as well, and at least the landing up there. Really, see that big red measure button? That's you. So once you get your point on whatever it is, just hit measure. What I like to try is to maybe get this down to the bottom.
Okay.
And then that way the spear will be down there, and you can just reach out there and hit, eyeball to center that embed or whatever you want to do, and then basically just store a point. If you want to get one back at the concrete, just make sure it's not teetered or whatever. I don't know how in depth you want to get with it, but yeah, that's pretty much it.
As they head to the upper levels, Nate shares a few final tips, and Gage takes the necessary safety precautions before starting the measurements.
All right, got it.
As Gage completes his final measurements, he's eager to review the results, assess any deviations, and share the findings with his team for final adjustments.
There's some quick little measuring tools here that you can choose from. We're going to jump right into the elevation one. Okay. There's a little tutorial page every time you go into an app. You can say don't show again. But yeah, once you select your first point, that's going to become your reference. So we can tap that one as our reference, and then the next point that we tap, that's going to give me the difference to that. So between them 2 points, there's a 3/8 difference. If I click on the next point down the line, there's a 3/16 difference. It's pretty good.
Yeah.
And another 3/16 difference. And now we start getting to a 7/16 to a 1/2 inch. And then down the line of 15/16. But yeah, at least you got an idea of saying, hey, they're within reason for the next step, or they're not. So Yeah, right away. And that probably took us about, once we got up there and started getting going and taking the shots,
10 minutes, maybe.
10 minutes.
All I had to do was put that where it needed to go and press a button.
Yeah.
That easy.
Hit the measure button and it's going to store your information for you.
Yeah.
I mean, we were probably up there. I think I'll probably give you a total of a 2-minute rundown on how the software works. But yeah, once we got it set up, we didn't even have to set it up really. We're just collecting points out in space. So that's kind of the ease of it as well. Didn't necessarily need data, but yeah, it just starts up right away into the measure mode. So, and then, the benefit of this software as well is if you needed an answer quick, you can come out and get it for one, and then you can export this to a CAD file and send it off to whoever needs to review it.
And you could send it to your surveyors.
Yeah. One thing we didn't talk about is you could actually put the CAD file right in here, or even an IFC, a 3D model in here, and you can validate things against your measurements. So if I was to select them embeds, if they were on the CAD file, I can select them, put my point out there, hit measure, and then now I have the option to store that point, and now it has something to measure against. Right, so it's going to measure against the CAD file, and you can tell right away if it's in tolerance or out of tolerance. But if it's within tolerance, so you can define your own tolerances. I have a 1/4 inch set up here. That's what I usually run, but you can do 1/8 of an inch or whatever. It's going to be a green point or it's going to be a red point to tell you that you're within tolerance right away. So I know we came in here and we did the little checks or whatever this way. But if you had that set up, these orange dots would be green or red to let you know, hey, right away I know if I'm in tolerance or not.